Okay, here's example 3 with right triangle trig and evaluating trig functions, things like that. So we're given that the cosine of theta is the square root of 6 divided by 3. And we're told to find the exact values of the other 5 trigonometric functions of theta. Okay, so this is all we're given here. We don't have any pictures to work with or anything. So let's go ahead and make one. Okay, we're going to make a picture for ourselves. So let's draw a triangle. So we're going to draw a right triangle here. Okay, here's our right triangle. Darken that a little bit. Here's our right angle. We'll put theta over here. So we can really draw this however we want, but let's just put the right angle over here and then we'll put theta over here. So what I mean is, we could rotate this triangle. We just draw it really however we want. We can label it however we want, just as long as we're consistent and we do it correctly. So cosine of theta is the square root of 6 over 3. Remember, the cosine is the adjacent side over the hypotenuse, right? Okay, so the cosine is the adjacent side over the hypotenuse. So there's actually going to be a few different ways we could label this triangle, but let's label it, let's keep it simple and we'll just say, okay, if cosine is adjacent over hypotenuse and we're given that the cosine of theta is the square root of 6 over 3, well, let's just say that square root of 6 is the adjacent side and 3 is the hypotenuse. Okay, we'll just say that just for simplicity's sake. So this is going to be root 6 and this is going to be 3. Okay. So there are other ways we could have labeled this, so let me just point that out real quick. We could have thought of that as cosine of theta equals root 6 over 3 divided by 1. So then that would be adjacent and hypotenuse. So we could have said, well, okay, let's say the adjacent side is root 6 over 3, okay, and then the hypotenuse would be 1. That's completely fine, that's still going to have the same cosine. The cosine of theta will still be root 6 over 3. But it's going to make the math a little more complicated, and we really don't want to mess around with that. So while that is doable, it's probably not the best way to go about doing it, because it will make things more complicated, and we want to keep them as simple as possible. So we should just leave this as root 6 and 3. Okay? So again, cosine of theta is adjacent over hypotenuse, root 6 over 3, and let's just not think about it the other way. Okay, so that's that. Now we're pretty much where we were when we had examples 1 and 2, right? Where we're given a picture, and we were given the angle, and we were given 2 sides of the triangle. Then we had to figure out the other side, and then use that to get the other, or to get the trig functions. So now we're pretty much where we were in examples 1 and 2. So let's go ahead and continue like we did there. So first we have to find this missing side. So let's call it x. So now we have to use the Pythagorean Theorem. Okay, so x squared, okay, the length of this side squared plus the length of this side squared equals the hypotenuse squared. Okay. So if you take the square root of 6 and square it, you just get 6. 3 squared is 9. So then x squared is 3. Okay, subtract 6 from both sides. Now we take a square root of both sides. All right. And again, there is a positive and a negative root, just like in examples 1 and 2. There's a positive and a negative root, but we're only going to take the positive root because x represents the length of the side, the length of a side of a triangle. So x equals this positive square root of 3. So x equals positive square root of 3. Okay, so now that we have that, we can start evaluating the trig functions. So there's going to be a little more messy algebra involved, not really too bad, but a little more messy compared to the first 2 examples anyway. Just some little subtle details worth pointing out. So let's set off some space over here. Okay, so cosine of theta we're given, so we don't need to write that down because we're just looking for the exact values. Remember, exact, so don't approximate any square roots with decimals or anything like that. Just leave everything exact in terms of square roots of the other 5 trig functions. So cosine's already given to us, so let's figure out what's sine of theta going to be. Well, sine of theta is opposite over hypotenuse. Okay, we just found out the opposite is the square root of 3, and the hypotenuse we were given is 3. So the sine of theta is opposite over hypotenuse, which is root 3 over 3. Okay? So if you have to rationalize the denominator, or if you like doing that, you can leave it like this. Of course, that'll be how you want to leave it. But if you don't like doing that, or if you want to simplify it as much as possible, because to me that's not really simplified as it can be, because what do you have? You have root 3 divided by root 3 squared. Okay? So 3 is the same thing as the square root of 3 squared. So you could actually just simplify that and say 1 over root 3. Okay? So either way is totally fine. But it does depend on your instructor and what the rules are for your course in particular. So just be mindful of that. But you could also write this as 1 over root 3, which I think is more simplified. But if you think about it, what's the harm in putting a square root in the denominator? Why can't we do that? No real reason. Cosine of theta we're given, but let's go ahead and rewrite it anyway because it'll make the rest of the problem a little simpler. So this is root 6 over 3. Okay, so we'll just rewrite it here just to be complete and thorough. Tangent of theta. Okay, tangent of theta. So theta, the tangent of theta is the opposite side divided by the adjacent side. So the opposite side is root 3, the adjacent side is root 6. Okay, so opposite and adjacent. So let's actually come down here. So this is going to be root 3 over root 6. So there's a couple different ways to think about this one. So if you have the square root of something on top divided by the square root on the bottom, you can put the whole thing under square root. Okay? So that's going to be root 3 over root 3 over 6 like this. 3 over 6 simplifies to a half. Okay? And then we can rewrite that as square root of 1 over square root of 2. Square root of 1 is just 1. Root 2 cannot be simplified. So 1 over root 2 would be the answer there. But if you're compelled to rationalize the denominator, or if you have to, then you can multiply by root 2 over root 2, and you'll get root 2 over 2. But again, I really don't think that's simplified. But if you insist, or if you have to, then that would be root 2 over 2. Okay. So, all right, those are the, so we found 2 of them, right? We were given cosine, and we found these other 2. Now, since we have sine, cosine, and tangent, the other 3 trig functions are going to be easier to get, right? So cosecant, remember cosecant of theta is just the reciprocal of sine, right? And if the sine of theta is 1 over root 3, okay, the sine of theta is 1 over root 3, then the reciprocal is just root 3 over 1, which is just root 3, okay? Or, if you had it like this, then you would say cosecant of theta is 3 divided by root 3, but then you would rationalize the denominator if you had to, and you would get 3 root 3 over 3. The 3's cancel, and you just get root 3 anyway. So either way, you're going to get the square root of 3 for the cosecant of theta. Okay? So notice we didn't use this triangle at all, right? We could if we wanted to, just remembering that cosecant is the hypotenuse over the opposite. Okay? But it's really better to remember that cosecant of theta is the reciprocal of sine of theta. Okay? Likewise, secant of theta equals, let's see, so if cosine of theta is root 6 over 3, then the secant of theta is the reciprocal of that, which is 3 over root 6. Okay, okay, so 3 over root 6. So in this case, if you rationalize the denominator, what's going to happen? So 3 over root 6. So if we rationalize the denominator, we'll get root 6 over root 6. We're going to multiply by that, so we'll have 3 root 6 over 6, which is root 6 over 2. Okay? So is that necessarily any better? It depends on what you need to do with it. Okay? If you have to rationalize the denominator, then yeah, you're going to want to do that. But if you don't have to rationalize the denominator, there's no reason that this one's any better than this one. Okay? So I can't really stress that point enough. Cotangent of theta is, so just like these two were reciprocals of these two guys here, cotangent of theta, remember that's the reciprocal of the tangent of theta. So if tangent of theta is 1 over root 2, we just take the reciprocal and we get the cotangent of theta. So 1 over root 2, the reciprocal is root 2 over 1, which is just root 2. Okay? Or just like with the sine of theta, if you wanted to use this one, root 2 over 2, then you would have cotangent theta equals 2 over root 2, and then you would rationalize the denominator, and then you would get 2 root 2 over 2. 2's would cancel, and you'd end up with root 2 anyway. Okay, so either way, cotangent of theta equals the square root of 2. Okay, so that's it for example 3, and this is the answer here. Technically, the cosine is not part of the answer because we were only asked to find the exact values of the other 5 trig functions of theta. So in our final answer, we probably really shouldn't include the cosine here because that was given to us. So the answer to the original problem statement is these 5 trig functions here. Okay? And whether you use this one or this one, or this one or this one, depends on whether or not you have to rationalize the denominator or not. Okay. So anyway, that's example 3, which we saw was not a whole lot more difficult than examples 1 and 2. Okay. See, the only difference is we were given this, only this in the beginning. Okay, just the cosine. We weren't given any pictures or anything. But then we said, okay, well, if cosine is adjacent over hypotenuse, let's just say that's the adjacent side, and that's the hypotenuse. And that's how we drew our picture. And then from there, it was really just like examples 1 and 2. Okay. So that's it for example 3 with right triangle trig.